Welcome friends, let's keep learning and exploring Ansible with Dev Linux. In the last video or lab exercise, we learned about variables, their scopes, and our work was not yet done. There are many things that we will be exploring and learning about variables. But at the foundation level, we covered a good deal of exercises and things. Now I'm going to quickly run one Adhoc command Ansible. Let's run it on the local host only using the default command module pwd. I'm just running that same system command and the output is there. You run any other command that returns a result. Okay, for example, that. And of course, you can use the other module called cell to run a system command, and this time we run something else. Systemctl status of ssh_t, and we have covered these two modules in the very beginning. So you see the output here. Now we can pipe and grab for, let's see, this word active. Using the default command module, we cannot use the pipe thing. Okay, so if I remove this thing shell and type command, that is the default thing. So you type it or you don't type it, it doesn't make any difference. But let's run it with the pipe thing, pipe thing. So it doesn't work. Okay, now let's run it again. So what I'm trying to show you here is when we use the ad hoc command and we run a system command like this one, so we get the output on our screen. But do we get output or results when we are running system commands inside a playbook? Let's create a playbook and call it register, for example. Name of the place, run a system command and store the result, of course, in a variable. Now, gather facts, I'm disabling it. Host, so I have my web server running currently and Docker as well. Tasks, name of the task, um, list the directory contents of slash where slash log, for example. Okay, using the command module. So ls-l, instead of ls-l, I'm going to use 1. When you use 1, it will just give you each item on a separate line without details. Dot dot dot. I'm not storing the result as of now. Just let's see what happens. So Ansible dash playbook and this playbook syntax check. It's clean, good. Let's run it and see what happens. Play name, task name, and changed means you know very well some action was done, something was executed, but there is no result for both the hosts, as you can see here. Okay, finally we got that play recap thing. Now let's edit this playbook, and just below that command module, we use the keyword register and specify a variable name that will hold the results, not just the value. We should call them results. Okay, so results, because why results, I'll show you, or output, whatever you call it. Okay, it's not a mandatory thing to call it in a particular way. So let's say ls output. Now that we have the output stored in the variable called ls output, we can print it. So now another task is print the results using the debug module, of course. Okay, because we made some significant changes to our playbook, let's check the syntax. Good. Name of the play, name of the task, first task. Now we see some result there. Okay, for both the servers. See, print the results. Okay, so here we didn't get any result, as you know. Now print the results, we created that separate task, and message, we provided the variable name to this message thing. So you observe these curly brackets and square brackets. Okay, so curly brackets mean um, dictionary. Okay, Python dictionary, and square brackets mean we have a list object. Okay, so here it is a list thing command. So in this dictionary we have this command as the key. Changed is the key, the value is here. After comma another key is there, then the value can be a another dictionary, another list, or another tuple, etc. Here this is a key and the value. Okay, return code is the key and the value is 0. Okay, for std error, because there was none, so we have an empty string here. In the terms of standard error underscore lines, we get a list, not a string, and we have an empty list there, as you can see. Okay, now std out, similar to std error, is a the value is a string. Okay, here it's an empty string thing. Here we have a string, a long string up to this. Then we have std out lines, because similar to std error lines, it contains a list object. So brackets are there, square brackets. Now this is the list. Okay, because of ls-1, each item is on a separate line. That is the nature of the command ls-1. Okay, if you don't use -1, then it will print like this. Now let's scroll up again. Same thing for the other host also. Okay, now when I say Python list or Python dictionary, so we'll cover them when we learn about Python, but here a little bit we can understand for a better understanding. So this is a list. Why? Because each item is separated by a comma, and all the items are inside this pair of brackets. Let me show you. I have my Python running in here. So if I give some name, for example, items equal this square brackets. Okay, here the square brackets have something in them. Okay, in terms of standard error, etc., there is nothing. So type of the object items is what? It is a list, as you can see here, which we noticed here as well. Now, what is this thing? Type. It's an empty list. Okay. Here we see list, not empty or full or half full. That's a different thing. But of course, you can use the length function here to check, and it will tell you 0 means there is nothing there. It's an empty list. Okay. Now, let's use the same thing here. Let's give some item in there. A for example, B for example, and some number 99. Okay. Now length items, and there are three items in there, or three values, you can say, elements more appropriately. Okay, so here std outlines is a list. Okay, so let's copy this entire thing. Std outlines, let's say result here. Okay, enter. Let me adjust the window. So now I want to print the values. Okay, so as you can see here, each item element or value is separated by a comma, as we did here manually also in this case, but they are separate elements from one another. And again, in the result, when we print it, we see those square brackets. Same thing here we see. Okay, so this is a Python list. Okay, once again, just to make things, for item in result, print item. Now you see a proper listing through a loop. We printed the items present in the list. So this is a Python list. Similarly, uh, these curly brackets are dictionaries. Okay, these curly brackets. I'm not going to give you an example of dictionary in the Python editor. You can try it on your own, but we'll cover them as and when required. So we have what we have done now, dot, because we know that std out underscore lines we can directly use, which is a list. So instead of printing out everything, right, the dictionaries, the strings, and other items, stdirr, rc, we don't want them, right? We just want this thing, std out lines only. So let's print it. Oh, what happened? ls output name print the results here. Some problem. Output underscore lines. Oh, incorrect. It is std underscore std dot std underscore std out underscore lines. Dot std out underscore lines. So let's run it. So it was a typo. I said it, but I didn't type it. Okay, the list we got. Okay, so std out underscore lines, which was the key in the dictionary, and the value was a list. And we, when we refer to the key, we got the the list. Okay, so the list is here, which has been assigned to the message thing. Okay, which is printing the uh, result here. So we have filtered out our result, our output for both the hosts, as you can see. So here you see, this is how we store output of any command you run, and use a keyword, a register, and a variable name. Okay, it doesn't matter how many tasks you have, how many times you are registering the results. Of course, it depends on your system. uh, we can say capacity, of course, right? Because this is all happening in the memory RAM. So if you have a large output and you are storing it in a variable, your system performance may be, you know, noticeably slow, degraded, but that is another thing. So I would like to add one more thing here, that print the results when. So we have a condition, and I have introduced this condition thing to you already. So when yum, for example, yum.log is present in this list, the word in I have to mention there, okay, because this item is present in this list. Now that makes sense. Good. So the item is present, and that's why we see the result. Now let's say I remove this .log part and just keep the yum part there and run the same playbook again. Here in, you see yum.log. So it's an independent item in the list, and there is no such item in the list as just yum, but yum.log is there. Okay, that's why the task was skipped for both the servers or hosts. But what if I am interested in partial match only? So instead of std out lines, which is a list, I can use std out, which is a string. Or I can do this also, that print the list but check in the string lines. Okay, print the list but check in the string. So string is .std out. Once again, okay, print the list but check in the string .std out only, which is a string. So a partial match will also work here because the yum word is found in the string. Let's see. The result is there. So we are printing the list, but we are checking in the string, and partially this word is found, yum. Again, without this thing, underscore lines. Check in the string only, check in the string only and print only the string. We can run it. You see, we are getting a long string only. And in the string, the word yum is found here. Of course, if you type it like this yummy and then expect it to work just fine, then it is not so yummy. It will be a bitter experience for us. So the word yummy is not found and the task was skipped. You can make a note of this playbook as shown here, and I think this should be quite enough for this exercise. And remove this, and outside I can mention single quotes. So I change the order of the quotes. Okay, I just change the type of the quotes. Okay, so beginning with this with the single quote only and ending it also with the single quote. And the word I'm interested in is in double quotes. So I, and here we don't need curly brackets. So the word yummy is not found as we know. It is, let's use yum to, we can say something else also, messages for example. Messages, messages is a file which is present there, as I know this file is present there, of course. So we got the result messages. So the thing is, when we are checking in a in a list, the exact match is required. Okay, by exact match, I don't mean case sensitiveness here. Of course, case sensitiveness is applied, small case, capital case, it does matter. But what I mean is the word has to be exactly there. Okay, so if it is secure dash this timestamp, then it has to be that way only, or this way, whatever it is there. Okay, the exact word has to be there because in the list the comparison is against each element, each item. Okay, if I say Anna, then Anna is not found here, but anaconda is found there. Okay, so partial match will not be considered. Anna is has to be an independent and a separate item in the list. But when we talk about a string, everything is just one single item. So that is the difference. Std out underscore lines. Here also lines I am mentioning. Done. Well, we did not print what the condition was, okay, which we could specify as the as the name of the task itself. Print the results if the file messages is present. That's it. So whatever conditions you are using, it should be it is wise to, it is advisable, it is recommended that we clarify it when we are running task or plays, so that we know what we are doing. Okay, if the file messages is present, which is certainly present, as we know, where it is here as a separate item in the list. So guys, I hope you enjoyed this lab exercise video, and thank you for your support. Bye bye. Good night.